morning everyone. Today we will discuss about different type of polymer. Natural rubber. Rubber is a natural polymer and possesses elastic properties. It is also termed as elastomeric polymer. In elastomeric polymers, the polymer chains are held together by the weak intermolecular forces. These weak binding forces permit the polymer to be stretched. A few cross links are introduced in between the lines, which help the polymer to retract to its original position after the force is released. Rubber has a variety of uses. It is manufactured from rubber latex, which is a colloidal dispersion of rubber in water. This latex is obtained from the rubber tree, which is found in India, Sri Lanka, Indonesia, Malaysia, and South Africa. Natural rubber may be considered as a linear polymer of isoprene is called cis-1 for polyisoprene. Here is the structure of natural rubber. The cis-isoprene molecule consists of various chains held together by weak van der Waals interactions and has coiled structure. Thus, it can be stressed like a spring and exhibit elastic properties. Vulcanization of rubber. Natural rubber becomes soft at high temperature and brittle at low temperature and shows high water absorption capacity. It is also soluble in polar solvents and is non-resistant to attack of oxidizing agents. To improve upon these physical properties, the process of vulcanization is carried out. This process consists of heating a mixture of raw rubber with sulfur and appropriate additive at a temperature range between 373 to 415 Kelvin. On vulcanization, sulfur form cross-link at a reactive sites of double bond, and thus the rubber gets stiffened. In the manufacture of tire rubbers, 5% of the sulfur is used as cross-linking agent. The probable structure of vulcanized rubber are molecules are depicted below. Synthetic rubbers. Synthetic rubbers is an vulcanizable rubber-like polymer which is capable of getting stretched to twice its length. However, it returns to its original shape and size as soon as the external stretching force is released. The synthetic rubbers are either homopolymers of 1,3-butadiene, derivative of copolymers of 1,3-butadiene, or its derivative with another unsaturated monomer. Preparation of synthetic rubbers. Neoprene or polychloropropene is formed by the free radical mechanism of chloropropene. It has superior resistance to vegetable and mineral oils. It is used for manufacturing conveyor belts, gaskets, and hoses. Buna N. Buna N is obtained by the copolymerization of 1,3-butadiene and acrylonitrile in the presence of peroxide catalyst. It is resistant to the action of petrol, lubricating oil, organic solvent. It is used in making oil seals, tank lining, etc. Polymer properties are closely related to their molecular mass, size, and structure. The growth of the polymer chain during their synthesis is dependent upon the availability of the monomer in the reaction mixture. Thus, the polymer sample contains chains of varying length and hence its molecular mass is always expressed as an average. The molecular mass of polymer can be determined by chemical and physical methods. A large number of polymers are quite resistant to the environmental degradation processes and are thus responsible for the accumulation of polymeric solid waste materials. These solid waste cause acute environmental problems and remain undegraded for quite a long time. In view of the general awareness and concern for the problems created by the polymeric solid waste, certain new biodegradable synthetic polymers have been designed and developed. These polymers contain functional groups similar to the functional group present in biopolymers. Aliphatic polymers are one of the important classes of biodegradable polymers. Poly-beta hydroxybutyrate, co-beta hydroxyvalerate. It is obtained by the copolymerization of 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. BHPV is used in specialty packaging, orthopedic devices, and in controlled release of drugs. BHPV undergo bacterial reduction degradation in the environment. Nylon 2,6. It is an alternating polyamide copolymer of glycine and aminocaproic acid, that is CH2 5COH and NH2, and is biodegradable. Besides the polymer already discussed, some other commercial important polymers along with their structures are given below. Polypropene. Propene is a monomer and structure is CH2 CH3 whole N. Uses manufacture of ropes, toys, pipes, fibers, etc. Polystyrene monomer is styrene. CH2 CH C6H5 whole N. An insulating wrapping material. Manufacture of toys, radio and television cabinets. PVC vinyl fluoride. Manufacture of raincoats, handbags. Vinyl flooring, water pipes. Urea and formaldehyde for making unbreakable cups and laminated sheets. Glyptal, ethylene glycolic acid, manufacture of paints and lacquers. Bakelite, phenol formaldehyde for making combs, electric switches, handles of utensils and computer disks. Some other polymers we will see. Nylon 6. 66. It is prepared by the condensation polymerization of hexamethylene diamine with adipic acid under high pressure and at high temperature. Nylon 66 is a fiber forming solid. It possesses high tensile strength. This characteristic can be attributed to the strong intermolecular forces like hydrogen bonding. These strong forces also lead to close packing of chain and thus impart crystalline nature. Nylon 66 is used Nylon 66 is used for making seat bristles for brushes and in textile industry. Nylon 6 it is obtained by the heating of caprolactam with a high temperature. Caprolactam. Nylon 6 used for the manufacture of tire cords, fabrics and ropes. Polyesters. These are polycondensation product of dicarboxylic acid and diols. Dacron or terylene is the best known example of polyesters. It is manufactured by heating a mixture of ethylene glycol and terephthalic acid in the presence of zinc acetate antimoney trioxide catalyst. As per the reaction given earlier, terylene is seize resistant and used in blending with cotton, wool fiber and also as glass reinforcing material and safety helmets, etc. Phenol formaldehyde, bakelite and related polymers. Phenol formaldehyde are the oldest synthetic polymers. These are obtained by the condensation reaction of phenol with formaldehyde in the presence of ether, an acid or a base catalyst. The reaction starts with the initial formation of ortho or para hydroxymethyl phenol derivatives, which further react with phenol to form compounds having rings joined to each other through CH2 groups. The initial product could be a linear product Novolac used in paints. Novolac on heating with formaldehyde undergoes cross-linking to form an infusible solid mass called bakelite. It is thermosetting polymer which cannot be used or remolded. Bakelite is formed by cross-linking of linear chain of the polymer Novolac. Bakelite is used for making combs, phonographs, record, electric switches, handles of various utensils. Here is the structure of bakelite. Melamine formaldehyde, another polymer. Melamine formaldehyde polymer is formed by the condensation polymerization of melamine and formaldehyde. It is used for manufacturing of unbreakable crockery. Thank you.